In this video, we're going to derive the height of a projectile. And so the way that works is, let's just say we had a ground that looks something like this. And we're going to say we have a ball on the ground right here. And when this ball is kicked into the air, the path that the ball makes looks something like this. Now, our goal is to figure out the maximum height that this ball reaches, which is at this point right here. And so we're just going to label this height right here. And we're going to label this height a height of h. And so our goal is to figure out what h is. Right? What is the maximum height that the ball will reach when it's kicked into the air? Now, we only really care about the motion of the ball until the point where it reaches its maximum height. Right? So we don't care about anything after the point of the maximum height. This is all we really care about, is up to this point. And we're going to say that we're given the initial velocity that the ball is kicked at. So this would be the initial velocity of the ball. We're going to label it v0. And also, we're going to say that the launch angle of the ball when it's kicked is theta. And of course, we know the acceleration due to gravity, right, is just g. So really, we're finding what the height of the projectile is at this maximum height, right, in terms of v0, theta, and g. Now, if we're finding the height of a projectile, we're only really considering the motion of the ball in the vertical direction, right? Because height is a vertical, it's pretty much what's the vertical displacement of the ball from this position to this position, right? The vertical displacement of the ball from this position to this position. That's all it is. So we're only thinking about the motion of the ball in the y direction, in the vertical direction. And we know when thinking about the vertical motion of the ball is going to experience an acceleration. And we know it's a constant acceleration, right? So we could use a kinematics equation. And to figure out what kinematics equation we could use, we got to figure out what quantity we want to know and what quantities we already know. So, the quantity that we want to know is, of course, the height that the projectile reaches, which refers to the vertical displacement of the ball. All right, so that's just, we want to know what delta y is. Now, for the quantities that we know, we of course know the acceleration due to gravity, right? So we know the acceleration of the ball in the y direction. Now, there's another thing that we know. It may not look like it's present here, but if we were to divide v0 into its components, really we have x component and y component, right? We have vx0 and vy0. Right? We only care about the vertical motion of the ball, so we only really care about vy0. Right? We also know what vy0 is, because we know vy0 can just be expressed in terms of v0 and theta, right? So that works for us. Right? We can say that we know vy0, which is of course the initial velocity of the ball in the vertical direction. Now, what else do we know though? Right? We know to figure out what kinematics equation to use, we got to have some third variable that we know. We need to know some third quantity that we know. Well, when the ball reaches the maximum height, the vertical velocity of the ball at this point, when it reaches the maximum height, has to be 0. Because that's when the ball reaches its maximum height, and eventually it'll go from a positive vertical velocity to a negative vertical velocity. So at this point, the vertical velocity has to equal 0. And so our final vertical velocity at that point is 0. And so given these three things that we know, and the one thing that we want to know, we can figure out what kinematics equation to use. And we know that the kinematics equation that we would use is this. Vy squared equals vy0 squared plus 2ay delta y. Right. And so basically this is the idea, right? We know that vy equals 0. So really this right here is just 0. So really what we have here is we have 0. Now, this is just vy0 squared. And we know vy0 is just v0 sine theta, right? v0 sine theta. And then we're just adding 2ay. Now, ay is the acceleration in the y direction, which is just the acceleration due to gravity. And so really, that's just the acceleration due to gravity. Except we have to put a negative sign in front of it. And the reason why is because the acceleration due to gravity points in the downward direction, right? It points in the opposite direction that the ball is moving vertically, right? G points in the opposite direction. So we have to put a negative sign there. And delta y refers to the vertical displacement of the ball. And it goes from a position of a vertical position of 0 to a vertical position of h, right? So really, our vertical displacement is just h minus 0, or just h. And so simplifying this, really this is just squaring v0 sine theta. So squaring what we have inside this parentheses is just going to be v0 squared sine squared theta. And then right here we have a negative sign, so this is just going to be minus 2gh. All right, I'm going to add this to the other side. So we get 2gh equals v0 squared sine squared theta. And then we can just divide 2g on both sides. And so we'll get that h is equal to v0 squared sine squared theta all over 2g. And so this right here is the maximum height that the ball will reach. And so yeah, that's pretty much the whole idea. And it's, of course, it is in terms of these three things: initial velocity, launch angle, and acceleration due to gravity. That's pretty much would be the maximum height that a projectile reaches. So that's pretty much it.